This video examines output tracking for the hot air temperature controller. The hot air temperature controller outputs to a summer whose output is the fresh air damper opening. To configure output tracking, we begin by asking the same two questions as in the previous video. When must output tracking be active? When the valve block for the fresh air damper is on local. What is the appropriate value for the controller output when output tracking is active? When control is active, the summer computes the fresh air damper opening from the output of the hot air temperature controller and the output of the characterization function. For tracking, the relationship is rearranged to compute the hot air temperature controller output from the fresh air damper opening. The analog value for output tracking is the output of the valve block expressed as percent open less the output of the characterization function. To provide this input to PID block, a summer must be configured to subtract the output of the characterization function from the fresh air damper opening. The mode of the fresh air damper is displayed to the left of its symbol on the graphic display. Let's switch the fresh air damper to local. But as discussed in the previous video, the scrubber duct inlet temperature loop is unstable under these conditions, so we also switched the fuel gas valve to local. The hot air pressure controller and the baghouse inlet temperature controller will perform satisfactorily, so they remain on automatic. With the fresh air damper on local, the hot air temperature controller is tracking. The indication AUT star means that the controller is on auto but is tracking. Currently, the output of the characterization function is 61.9%, and the opening of the fresh air damper is 61.8%. Subtracting the output of the characterization function from the opening of the fresh air damper gives a value of minus 0.1% for the output of the hot air temperature controller. Let's demonstrate output tracking for the hot air temperature controller. The fresh air damper is on local, and the hot air temperature controller is tracking. Change the fresh air damper opening to 65%. The most obvious consequence is a decrease in the hot air temperature. Let's place the simulator on hold and examine the tracking. The fuel gas valve remained at 82.5% open, so the output of the characterization function remained at 61.9%. With an opening of 65% for the fresh air damper, the tracking calculations give a value of 3.1% for the output of the hot air temperature controller. Return the simulator to run. Then change the opening of the fuel gas valve to 85%. This puts in more heat, so both the hot air temperature and the scrubber duct inlet temperature increase. Opening the fuel gas valve to 85% causes the output of the characterization function to change to 66.9%. With an opening of 65% for the fresh air damper, the tracking calculations give a value of minus 1.9% for the output of the hot air temperature controller. Now let's return to full automatic. The scrubber duct inlet temperature controller is unstable when the fresh air damper is in local. Consequently, the sequence must be to first switch the fresh air damper to remote before switching the fuel gas valve to remote. The fresh air damper is 65% opening. Observe the opening of this damper as we switch the fresh air damper to remote. The transition from local to remote is bumpless. The damper opening changes smoothly but very slowly, eventually attaining 66.7% open. The hot air temperature controller provides the feedback trim to the ratio controls. Such controllers are normally tuned to respond slowly. The fuel gas valve is 85% open. The scrubber duct inlet temperature controller is tuned more aggressively, so the response will be fast. But observe the fresh air damper or the fuel gas valve opening as we switch the fuel gas valve to remote. The transition to automatic is bumpless, but the scrubber duct inlet temperature controller returns to its set point more rapidly. The next video examines output tracking for the loops associated with the hot air dampers.